Okay, hi everyone. My name is Josh Siegle. I'm a senior scientist at the Allen Institute for Neural Dynamics in Seattle. I'm a longtime Neuropixels user, and I oversee the development of the Open Ephys GUI. Open Ephys GUI is a general purpose application for high channel count ephys experiments. Software development team is distributed between Allen Institute and Open Ephys headquarters in Atlanta. Core application is cross-platform with versions available for Windows, Mac, and Linux. However, Neuropixels plugin currently only runs on Windows due to limitations of the Neuropixels API. I would say the distinguishing feature of Open Ephys GUI relative to other software in this domain is its plugin architecture. This means that all of the data is processed by plugins that are compiled separately from the main application. This makes it easy to configure a custom signal chain for different experiments or use the same signal chain with a variety of different data sources. And then plugins can be easily added and removed via GUI's built-in plugin installer. There are currently more than 50 officially supported plugins, but if there's some feature that you need for your experiments that requires a new plugin, we would be more than happy to help you figure out how to build it or figure out how to get the similar functionality by combining existing plugins. So the GUI was originally developed to work with the Open Ephys acquisition board shown here in the upper left. This is a low-cost open source device that can stream data from tetrodes and passive silicon probes. And it still works very well with Open Ephys acquisition board, but thanks to the plugin architecture, it now includes plugins for a variety of different types of hardware. So one of these is the latest Open Ephys acquisition system called Onyx. This is works with Neuropixels, Intan head stages, UCLA miniscopes, and also includes a torque-free commutator that's optimized for freely moving recordings. And with this system, it's possible to record from the same animal continuously for many weeks with minimal impact on behavior. So if you're interested in freely moving neuropixels, that's definitely something worth checking out. But it also works with this system sold by NeuroNexus called XDAC, which now supports NeuroPixels as well. And it works with a variety of acquisition systems from Intan, including their recording controller and USB eval board. Can also interface with most National Instruments data acquisition modules. And of course, it works seamlessly with all NeuroPixels probes via plugins for IMAX PXI base stations and OneBox. So now I'm going to move on to a software demo. So yeah, this is what the Open Ephys GUI looks like when you first start it up. On the top, you have some settings related to audio and able to start and stop acquisition and recording, and a clock for monitoring the time spent acquiring data. On the left, you have a list of all the plugins that are available to build your signal chain. And you can take these and drag and drop them down here in order to build your signal chain one by one. But I think for today's demo, I'm going to show how to load a default configuration. So this is just in the file menu. When you first launch the GUI, this is what you see. So if you're not sure what plugins you need to use to build your signal chain, you can load one of these 3 default configurations. So there's one for Open Ephys acquisition board, one for reading data from a file, and one for Neuropixels. So in this case, we're going to click Neuropixels, and you can select which type of Neuropixels device you want to use. In our case, we're going to pick OneBox. I don't actually have a OneBox connected to the computer right now, but you can still use the plugin in simulation mode. So we're going to click yes here, and then pick 2 simulated Neuropixels probes that we want to use. So one Neuropixels 1.0 and one Neuropixels 2.0 4-shank. And then we hit launch, and it will automatically load this signal chain. So here we have 6 different plugins that have been that comprise our signal chain. On the left, we have the OneBox plugin. So this is what will actually acquire the data. This is a source plugin. Every signal chain needs some data source. But because of the plugin architecture, you can easily swap out different data sources just by deleting and replacing this plugin. Next, we have the record node, which is what will write data to disk. Then LFP viewer for visualizing continuous signals. bandpass filter for filtering the data, obviously, Neuropixels CAR, or common average reference, which is a method for denoising signals that's optimized for Neuropixels probes. And then we have the probe viewer, which I'll talk about a little bit later, which is basically it shows a heat map of channels over time. Oh, sorry. Okay, so yeah, let's focus on the Neuropixels plugin. So here we have a display of the overview of all the channels on the probe, which you can scroll around and zoom in. You can, if you want to select different sets of electrodes, you can choose one of these different electrode presets, such as bank B electrodes or tetrodes, to select blocks of 4 channels. You can also easily change the AP and LFP gain for the Neuropixels 1.0 probes. You can select the reference between external and tip. And if we start acquisition, we can actually view signals as a heat map overlaid on the electrode sites within this display. If we switch to this other tab, we can do the same thing for our 4-shank probe. This is a 2.0 probe, so we don't have AP and LFP gain settings, but we can change the reference between external and tip. And then a new feature that will be released very soon is this probe survey mode, which allows you to both visualize data in real time across multiple probes, but also to switch between different banks automatically to kind of get a high-level overview of what's happening across all the different sites on your probe. So to configure survey mode, you can first select the amount of time per bank or shank that we want to record. And then you can optionally save all of the data from the survey to disk if you want, or you can just use it for visualization. And then with this table, you can select which probes you want to include in the survey, and then also which banks or shanks to include in case it's a multi-shank probe. So for this 2.0 multi-shank, it actually has 4 banks. We're just going to sample from 3 of them and just 2 of the shanks, so it doesn't take quite as long. And then you can hit, let's expand this, and hit run survey, and then this will cycle through all the different banks and or shanks that you selected and give you an overview of activity across the probe. And once that finishes, you can visualize the heat map here. You can also save results as a JSON file if you want to do some analysis to optimize which sites you want to select. And then if you also go back to this view, you can now see the results of the survey overlaid on this visualization and use that to select which channels you actually want to record from. Okay, so now talking about recording itself. So this is done via this plugin called the record node. This gives you a lot of flexibility in how you save the data. By default, it uses this binary format, which it just saves the data as a flat array of N16s. But if you've installed the right plugin, you can actually record data directly to Neurodata without borders files by switching to NWB here. If you have lots of probes and you want to record them across multiple SSDs, you can just drag and drop another record node in and set that to record to a different file location. That makes it really easy to kind of flexibly distribute your data across different disks. But let's delete that for now. And then, yeah, an important feature of the record node is its ability to automatically synchronize data as it's coming in. So if your Neuropixels plugin either is generating its own sync pulse or receiving a sync pulse from another device, the record node can monitor those sync pulses in real time and figure out the exact offset and scaling of each of the probes. So one important fact about Neuropixels probes is that each probe has its own acquisition clock. And so you can't actually know that the samples are synchronized unless you perform either offline or online synchronization. But The Open Ephys record node can do this automatically. And so now that these sync monitors have turned green, we know that all of the timestamps that are being saved to disk will be pre-synchronized and can be analyzed immediately without having to do any offline processing. Okay, so I want to show some more visualizations, but before I do, I'm going to delete this OneBox plugin and drag in a file reader so we can look at some pre-recorded data. And then just going to select this file. And so this will load up some pre-recorded Neuropixels data, which you can here see via the LFP viewer. This visualization has a lot of flexibility to it. You can split the displays, so you can have independent views of the same data. You can change the time base. You can change the range of the visualization. And one thing that is super useful is if you pause the display, still acquiring data in the background, but you can go back in time and look at what happened a few seconds back, and even scroll around the data and inspect what was happening at an earlier point in time, which can definitely be helpful for if you miss something in real time and want to go back and check out what it was. That is easily doable with the LFP viewer. Another useful aspect of the display, if for Neuropixels data in particular, is this spike raster view. So you can set a threshold. So every time the signal crosses a threshold, it draws a vertical line. And if we change the channel height to something smaller and change the color scheme, we can now see a spike raster across the whole probe. And last thing I want to show is the probe viewer visualization. So this takes all the incoming data and plots it as a heat map. So time on this axis and channels on this axis. And this allows you to have a very nice high level at a glance view of activity across the entire probe. Okay, so stop that and go back to my presentation. Okay, so yeah, to try out the software yourself, you can head to openephys.org to download the GUI. All of the code is, of course, open source and hosted on GitHub. And to learn more about all the features I talked about, you can read the documentation at openephys.github.io/GUI docs. And if you run into any issues, feel free to post on Slack or send an email to GUI@openephys.org.